Hi everyone, welcome to this session. My name is Somjit Goswami. In this session, we will be looking at CAT Quantitative Abilities Rapid Concept Series. So this is a end-to-end algebra A to Z kind of a situation, which you can also refer to as a refresher course, which means 100% of the syllabus will be covered at one shot. There are a few pointers which I want you to pay attention to. Watch the video at 1.5x speed or even 2x speed, whichever is more apt for you. That will enhance your viewing experience. If you have any doubt, any query, anything that you would like to share with me, comment that down. Finally, relax. Okay, and let's start the session. So the first concept is algebraic identities. Okay. So typically algebra starts off by the identities. In this session, however, I'm not going to tell you a plus b whole square and all that. I will start off with the most important things which are important in identities. That is, first of all, everybody needs to know the factorization of a raised to the power n minus b raised to the power n when n can be even or odd. This is important. N can be anything, even or odd. In this case, two things you need to just remember. That is, this thing can be factorized as a minus b. So I am directly saying that a raised to the power n minus b raised to the power n is going to be completely divisible by a minus b. For that, n has to be even or odd, whatever. But the factorization of this thing is going to be a raised to the power n minus 1 plus a raised to the power n minus 2b plus a raised to the power n minus 3b square, so on till b raised to the power n minus 1. That's it. Okay. So this is an interesting concept that one needs to remember. This is important for your number system also. This is helpful in remainders. The second thing is the same for a raised to the power n minus b raised to the power n. But this time, n is only, please pay attention, only even. Okay, n is only even. In this case, a raised to the power n minus b raised to the power n will be divisible by a plus b also. So the factorization will be something like this: a raised to the power n minus 1. This time the terms will be negative alternately, okay, which is going to be a raised to the power n minus 1 minus a raised to the power n minus 2 b plus dot dot dot, and finally b raised to the power n minus 1. Okay, if you want to perhaps take a screenshot, you can take screenshot also. But for our purposes, which is more important, is a raised to the power n minus b raised to the power n divisible by a plus b? Yes, if n is only even. A raised to the power n minus b raised to the power n is divisible by a minus b? Yes, if n is even or odd. So a minus b to divisible is a factor, whatever is the case. The last thing which you should be remembering is the a raised to the power n plus b raised to the power n. Okay, this is divisible by a plus b if n is odd. This is very important, if n is odd. And if you are, if you want to know the factorization, this is going to be similar to this one: a raised to the power n minus 1 minus a raised to the power n minus 2b plus dot dot dot, lastly b raised to the power n minus 1. That's it. Okay, now obviously the thing that I want you to take from this session is that a raised to the power n plus b raised to the power n will always be divisible by a plus b only when n is odd. And similarly for other. For our purposes, this term, which is the other multiplication, this thing is not very important. But again, because we are learning identities, I'm giving you the factorized form as well. Okay. Now a couple of simple identities if you want to recall. So let's say a plus b the whole cube. A plus b the whole cube can be very easily remembered as a cube plus 3a square b plus 3ab square plus b cube. Okay. Similarly, if you have a negative sign over there, a minus b whole cube, so all the odd powers of b will be negative. So this one will become negative. This one is not an odd power, so this will stay positive. This will become negative. Now a cube plus b cube, that is equals to a plus b, this is important, a plus b into a square minus ab plus b square. Okay. And similarly a cube minus b cube, this is going to be a minus b multiplied by a square plus ab plus b square. Okay, these are some of the important things that you can remember. The others you already remember. One more thing which you can remember is a cube plus b cube plus c cube minus 3abc. So let me write that also here. A cube plus b cube plus c cube minus 3abc is a plus b plus c multiplied by a square plus b square plus c square minus ab minus bc minus ca. Typically, CAT has this idea that they will give you this a plus b plus c as 0. So if a plus b plus c is 0, then you can directly see, then I'm writing that thing also, a cube plus b cube plus c cube is equals to 3abc. This is something that has been asked as a standalone question in CAT also. Okay. Alright, so this is all for identities. Now let's go to the next topic, which is going to be important for us. So let's look at equations. So we'll start off by linear equations. The very first thing that I will ask you is that why they are called linear equations, okay? And why not anything else? So an expression of the form, let's say 2x plus 3y is equal to 6. Why is it called a linear equation? For a simple line, if you jot them down as a graph, you will always realize that this line is going to be a line, a straight line. Okay, obviously the slope is negative, so it is going to be a line like this. And because the graph is that of a line, so that's why these type of equations are called linear equations. Okay. Also, I would like to say that solving linear equations is always favorable simultaneously. If you have two equations, you can solve them simultaneously and you can get the answers to the solutions. Okay. Now let's move to number of roots. Okay. For linear equations, number of roots. So let's say a general form. So I haven't defined the general form of a linear equation, so let me define it over there. This is ax plus by is equals to c. This is the general form of a linear equation. So suppose we have two equations of the type a1x plus b1y is equals to c1, and the other equation is a2x plus b2y is equals to c2. Now obviously I will not go into too much of details. I'll directly give you the coefficient of x, y and the constant terms will give you the number of solutions. Okay, to make things a little easier for you, I will take an example. So the example will tell you. So suppose I take 6x plus 9y, that is equals to 20. This is one equation, and the other equation has 9x plus 13.5y is equals to 30. If you pay attention at the coefficients, you will realize the coefficients of x, y and the constant term can be written down as, okay, so I am writing this down, a1 by a2, then you keep a bracket like this, b1 by b2, then a bracket c1 by c2. Now whatever you know is whatever you get in these brackets will define whether or not you will get how many roots for the linear equation. If you get a equal to sign, you'll get something. If you don't get equal to sign, we'll get something else. Now let us look at the example. So if you pay attention, this is 6 by 9 is 2 by 3, okay, and 9 by 13.5. If you just multiply 2, you will get 18, and this one will become 27. 18 by 27 again is 2 by 3. So in other words, for the first set, I am getting a1 by a2 is equals to b1 by b2, and if you look at the other thing, which is 20 by 30, that is also c1 by c2, that is 2 by 3. So 2 by 3 here, 2 by 3 here, 2 by 3 here. So all of this a1 by a2, b1 by b2, c1 by c2, all the terms are equal. In other words, this is, you will have infinite solutions, and I'll tell you why you will have infinite solutions, because these are not different line, they are the same line. They are effectively same line but different points. So if you suppose you plot this thing, instead of these 2 points, I'm now looking at these 2 points. Okay, I'm just looking at the multiple of x and y. So effectively they're the same line. Okay, now let's take another example to understand the other topic. So let's let me erase the slide so that I have some space. Now let's take an example. Instead of an example, let's say in the previous case I had a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Suppose in the next stage I say the last term is not equals, which is a1 by a2 is equals to b1 by b2, but it is not equals to c1 by c2. In that case, what you will have is, this is something called as a inconsistent equations. Inconsistent equation means you will find no solutions. Please remember, in the first case we found infinite solutions. Here we will find no solution for a simple reason, because the coefficient of these two lines, a1x, b1y and c1, they are effectively parallel lines. Okay, so I can represent them like this. So their slopes are actually going to be equal. Okay, now the last idea, which is what happens when all the coefficients are unequal. That is, perhaps, I'm pretty sure you already know the answer to that, but what happens when all the coefficients are unequal? This is a consistent equations, and in this case, if you have two equations, a1x plus b1y plus c1 is equals to c1 and a2x plus b2y is equals to c2, in that case you will actually get something like this, and you will get a unique solution. Okay, so when the coefficients are all not equal, you get consistent equations, and in other words, you can also say there will be one unique solutions. Okay, that is very important. All right, now let's go to the okay, so in this session, let's start off by integer solutions or integral solutions. For any, linear equations, ax plus by is equals to c, you can have multiple solutions. Okay, so suppose I'm drawing a graph for this thing. Okay, for the value of a, it could be a increasing line or a decreasing line. But one thing that is for sure, that this line will have infinite solutions. A single line will have multiple solutions. What exactly is the solution? So solutions are the points x and y, and these x and y are typically the solutions for this line. Okay. Now the fact that it can have infinite solutions, but it can have only so many integer solutions. We know what an integer is. Okay, so let's look into a, let's say, example. So 2x plus 3y, that is equals to 8. You have to tell me the total number of positive integer solutions. Okay, so there is a typical algorithm that I use for these type of questions. They are very mechanical. The first thing is that, tell me what is the slope of this line. We all know that slope can be very easily calculated. Just write it in the terms y is equal to mx plus c. Okay, and calculate with, and just see whether m is positive or negative. In this case, it's a negative slope. What that means is this line will be decreasing line, and what that means is, as x increases, y keeps on decreasing. Okay, if x increases, y decreases. Okay, Similarly, if you see, suddenly if you say that x is decreasing, going in the negative direction, and you will directly at this point start saying that y is increasing. Okay, so from y at 1 it will be 2 and 3 and all that. Okay, so when x is decreasing, y increases. So this is a sort of an algorithm that I keep in check that helps students understand why the increment, decrement and all that business happens. Because when you get the first solution, so suppose I get the first solution, I can now say that x will decrease and y will increase, and the increment decrement will happen for x, the decrement will happen in the steps of the coefficient of y, and for y the increment will happens in the steps of the coefficient of x. I hope that makes sense. Now let's quickly find out the first solution, any solution. So just jot down for y equals to 0, this is going to be 4, x is going to be 4. Now the next solution, I don't really need to do anything, I just need to subtract 3 from 4 and get a 1, because I'm decreasing x and I'm increasing this thing, so I'll have a 2. The next possible number contender will be, I'll decrease it again by 3, so this will go into the negative domain. So this is going to be 3 minus 1, that is minus 2, and for this one it is going to be 4. Now please understand that the idea is we have to calculate the positive integral solutions. So 1 and 2 is the only solution pair that is acceptable. So it is not that always we have to have two equations and when we simultaneously solve them we'll get a solution. We can get integer solutions with just one equation, provided you know the slope of the line. You can predict that very quickly, and this prediction helps us to realize whether x is going to increase or decrease, and then we can apply the algorithm here. Okay, now let's take a little difficult sort of a question. In this question, I will have the first two things exactly similar, 2x plus 3y. Just let's increase the coefficient or the constant term to 763. Okay, here you will realize that because 763 is an odd number, it definitely will not go by 2. So what I will do is I'll try and subtract 3 from it, so I'll get 760. So the first solution pair can come at when y is 1. When y is 1, this is 760, half of that is 380. Now I have asked you, rather I have told you that this is a line that is decreasing. So what I need to do is either I will increase or I will decrease x. If I decrease y, this will go to 0 and the negative, that is not favorable. So what I will do is I'll increase y and decrease x. Again, I would like to ask you the increment and decrement, I hope you remember, will happen in the steps of x and y. So the next possible term will be 377. Decrement is happening in the steps of y, which is 3. And for this one, it is going to be 3. Increment is happening. So you can go on, but you will realize that 1, 3, this will take a lot of time. So at this point, quickly tell me a number for y. So, let's do this for y. So x and y. I want to get a, let's say, boundary conditions for this one. Okay, so let us subtract 2 from this thing. In other words, I'm substituting x as 1. So this becomes 761. 7 and 7, 14. 14 is not divisible by 3, so x equals to 1 does not satisfy. What if x is 2? This is 4. 763 minus 4 is 759. Now what is 759? 7 and 5 is 12. 12 and 9 is 21. 21 is definitely divisible by 3. So I know that x equals to 2 satisfies. Now x equals to 2 satisfies. At x equals to 2, this number is going to be 759, and 759 divided by 3 is 253. Okay. Now at this point, you have to be careful of whether to increase x or decrease. This is a bit complicated. That's why I keep on saying that the slope will always help us. अगर 2 से पीछे जाएंगे तो negative आ जाएगा, 0 आ जाएगा, is not favorable. So we have to increase x and we have to decrease y. But remember, if I go one step below 2, because I need to check that whether this is a boundary condition or not. If I go one step below this thing, I will have to subtract 3 from 2. That is not favorable, because if I subtract 3, this will go into the negative domain. So at this point, what will happen is that I will have to add to x, and I will add 3 to it, so this will become 5, and the next term will be 255. Okay, and so on and so forth. But that is again not our concern. So the boundary condition is 2 and the end one is 380. Okay, so either at this point, what you need to tell me is how many numbers are between 2 and 3, and the difference, the common difference is obviously of 3. So if you pay some, if you do some algebra, you will find the solution, which is, you can use the idea Tn is equal to a plus n minus 1d. Tn is 380, this is 2 plus n, I have no idea, d I know is 3, so this is 378. 378 divided by 3 plus 1, that is equals to n. Now let's see if I am getting this. 2 is 6 and plus 1, that is 127. So total you are getting 127 terms. So not very difficult, but then if you are a little observant, you can see another thing, which is, see, y starts from 1 and ends at 253. Okay, so y starts from 1 and goes all the way to till 253, and the common difference is 2. In other words, what is going to be the one term before 253? That is going to be 253 minus 2, that is 251. Okay, one term less than that and you will get at some number less than this thing. So 249. 1 all the way till 249, you will get total 125 terms. Does that make sense? Okay, I hope that does. And these two extra terms will add, so this will be 127. Okay, so I mean, this is again something that you have to see the pattern. If you are able to see the pattern, that's a great thing. If you're not able to see the pattern, nothing can be done, and you have to go a little mechanical. Okay, so that's it. Now we are looking at quadratic equations. We will start with the standard form of a quadratic equation. The standard form is that of ax squared plus bx plus c is equals to 0. We know this thing. Now, the reason why we are looking at the standard form is to predict the shape of the quadratic equation ka graph. Now, for a, being positive or negative are the only two cases that is possible, because a is a coefficient. It's a constant term that is multiplied to the x squared variable. If a is positive, we typically get a curve like this, an upward u, and if a is negative, we get a curve like this, a downward u. You can call them parabolas as well. They are parabola, in fact. So an upward parabola when a is positive, and a downward parabola when a is negative. So this is the shape of the graph of a quadratic equation. If you consider this to be a function f of x, then this is a quadratic function, and a quadratic function will have roots. Okay, now let us try and understand what a root is. So roots, we all know alpha, beta are the two roots for a quadratic expression. Any equation, be it a quadratic, let's say even for cubic, bicubic, biquadratic and all. So the degree, the highest order of a expression or a equation is a degree, and whatever is the degree, so in this equation the degree is that of 2, will predict the number of roots. So number of roots for a quadratic equation will be 2. So we are representing them as alpha and beta. Roots are typically also called as the zeros. When you substitute the value of the roots into the expression will become 0. That is the meaning of a root. Okay. Now let us try and understand how we can calculate roots. Okay. So the very first method is the one that we have been familiarizing ourselves from the school days, which is that of a factorization. This is also, I like to call it the mid split, the middle term splitting. So I'll take an example. So say x square plus 15x plus 56. So the middle term splits work in such a way that you have to give me two numbers, the product of which will be 56 and the sum of which will be 15x. Either if you are a little bit, good with maths, you know the numbers are 7x and 8x, in which case you can directly write the roots as x plus 7 and x plus 8. This is the factorized form of this expression, x square plus 15x plus 56. Or if you're a little slow, you can start off by the prime factorization of 56. So maybe 2 28s are, 2 14s are, 2 7s are, and because 7 is a prime, we'll stop at that. Club these 2 into 2 into 2, that is 8 into 7, 8 7s are 56, and you have the value. So when this method does not work, and I'll tell you, there will be certain quadratic equations in which the mid split will not work. In that, we will have to use the quadratic formula. Okay. And the quadratic formula, I think everybody knows it. I don't really need to emphasize. It is x will be minus b plus or minus b square minus 4ac upon 2a for the expression ax squared plus bx plus c is equals to 0. Okay. Now, suppose, I give you an expression. Let me give you an expression. X square minus 7x minus 2 is equals to 0. Now you can try the mid split over there. You will not find any numbers that will satisfy the product to be 2 and the sum to be minus 7. So in that case, we'll have to use the quadratic formula. So directly we can use, and quadratic formula can be applied in the ones that can be found out through the mid split also. That is going to be minus of minus 7 plus or minus. Why is it that we are doing plus minus? Because typically we get two conjugate pairs of roots. Okay, I have already mentioned that the quadratic equation will always have two roots, alpha and beta. Let's see. So minus 7 ka square is a 49, and 4ac is a minus 4ac is a 8 plus 8 divided by 2. That's it. Coefficient of a is 1. So you get 7 plus or minus root over, this is 57 upon 2. So you can at this point say that alpha will be this thing, beta will be 7 minus root over 57 by 2. And as you can see, both of them are conjugate pairs. Okay. No, I don't want to give a lot of elaboration in this one because this is more like a refresher session. So I'll keep it at that. Now let's go to the idea of nature of roots. Okay. First of all, we have understood the quadratic formula, and the quadratic formula is minus b plus or minus root over b square minus 4ac upon 2a. Now this term b square minus 4ac without the square root is called the discriminant. Okay, I will not write it, I'll just mention it. It is called discriminant. Now based on what the discriminant is, if it is less than 0, so for a discriminant d, we can typically have two cases. It can be less than 0 or it could be greater than or equals to 0. If the discriminant is less than 0, roots are imaginary. What does this mean? Basically, we will now go into the territory of complex numbers, which is not something cat will ever throw at you. So this is something that you will never find. We will always be looking at d greater than equals to 0. Now here also I would like to say that the two ideas are d greater than 0 and d being equals to 0. If d is greater than 0, always, please understand, we are always talking about the roots for the quadratic. Okay, when d is greater than 0, roots are real and they are unequal. This is important, the word is unequal. When d is equal to 0, they are real and equal. Please understand, there is one more branch that I would like to tell you. That branch is when D is a perfect square and when D is not a perfect square. Okay, when D is a perfect square, this is something for your, I mean, if a question is based on this, then you can remember it. Roots are rational, and if it is not a perfect square, roots are irrational. If you just remember the last example that I used, D or the discriminant was not a perfect square. In that case, the value that we received were irrational. Okay, anything that is inside the root is an irrational number. Okay, also, I mean, that is a very loose example, but then that is what it is. Now let's go to the next idea for quadratic equations, which is properties of quadratic equations. Now, what are a typical property of quadratic equations? So for a quadratic equation f of x, or you can also call it a quadratic function, f of x equals to ax squared plus bx plus c, that has roots as alpha and beta, properties, the first property is that of the sum of roots, which is alpha plus beta. Alpha plus beta will always be minus b by a. The other one is the product of roots, alpha into beta, that is c by a. Also, one more important thing at this point is a formation of forming a quadratic equation. Forming a quadratic equation with the help of the roots, I might add alpha and beta. We can do it like x square minus alpha plus beta plus alpha into beta, that is equals to 0. Now please remember, this is the way. If you have the roots with you, alpha and beta given, you can form the quadratic equation through the roots with the use of this idea, x squared minus alpha plus beta plus alpha into beta, that is equals to 0. Please understand, there is a negative over there. You have to be careful of this thing. Let us take an example that will make the idea concrete in your mind. So say, and this is a cat level question. So say if alpha and beta, I'll not write the entire thing, I'll dictate the question. Say if alpha and beta are the roots of the equation. Now I'm giving you the equation 3x squared plus 5x plus 1 equals to 0. Okay, then we have to find the equation whose roots are, you have to find the equation with roots alpha squared and beta squared. Okay, you can pause this video and try this out, but let me tell you that obviously you don't have to find the roots and then, you know, square the roots and then form the equation. Let's do this a little more elegantly. How we can do that is, for this expression alpha and beta, alpha plus beta can be very easily calculated as minus 5 by 3, right? Alpha plus beta is minus b by a minus 5 by 3, and alpha into beta is going to be 1 by 3. Now please remember, anything that has to do with quadratic equations, we will always use the properties. We will hardly have to use quadratic formula or anything. Even for cubic equations also this thing holds true. Now please tell me, what is it that they are asking? They have asking to form an equation with the roots alpha square and beta square. We have just now understood that thing we can do with the idea x squared minus alpha squared plus beta squared plus alpha squared beta squared. So this is the equation. Do I know the value of alpha square beta square? No. But do I know the value of alpha plus beta? Yeah. But do I know alpha square plus beta square? No. So let's, you know, just square them. So alpha plus beta the whole square. Alpha plus beta the whole square is alpha square plus beta square plus 2 alpha beta. I know this thing is minus 5 by 3. I'll write it directly. This is 25 by 9. Alpha plus beta, I have no idea, alpha square beta square. But 2 alpha beta I know is 2 by 3. So I'll just subtract 2 by 3 and I'll get alpha square plus beta square. If you take 9 as the LCM, you'll get 25 minus 6, that is 19 by 9, that is equals to alpha square plus beta square. Okay, just substitute that value. This is going to be x squared minus 19 by 9 x plus alpha and beta. So you can write this as 1 by 9 alpha beta ka whole square, this thing ka whole square. Okay, now at this point you can multiply 9 throughout and you can get something like a 9x squared plus this is going to be minus 19x plus 1. So this is the equation that we have to form. This is going to be the answer to the equation that we were supposed to form with these roots alpha squared and beta squared. Okay, that is all from quadratic equations. Okay, so in this session we'll be looking at polynomials, and typically this is important for the remainder theorem, and this remainder theorem is the algebraic remainder theorem. It basically is a very simple idea. We are here to find the factors of, so suppose, you know, there is an expression given to you as x cube plus, let's say, 4x squared plus x minus 26. Now we need to find the factors of this. You can either call it a function. In that case we will be factorizing this thing. Now obviously you know the idea. The idea is very simple. You have to first find out one root, that 2 from hit and trial. So suppose I substitute 1 as x as 1, so this will be 1 plus 4 plus 1, that is 5 minus 26 will not give me a 0. So the first root the first root x equals to 1 does not satisfy. Let's try that with x equals to 2. So this is 8. Okay, I can write it somewhere. You can remember this also numbers. This is 4 4s are 16 minus 2 minus 26. Now if you pay attention, 10, 8 and 2, 10 and 16, that is 26 minus 26 equals to 0. That means x equals to 2 satisfies. In other words, x minus 2 is a factor. Now you can use x minus 2 and do the long division method of, finding the quotient and then factorizing. But then there is a elegant way to do this thing through something called as a synthetic division. I will explain the synthetic division through that example only, so that we'll not find any problem. So the question that was given to us was x cube plus 4x squared plus x minus 26. We have already calculated that at f equals to 2 this is 0. So what I need to do is I need to form a layout like this, and I'll just need to write the coefficient with the signs. So 1, you can write it like plus 4 minus plus 1, but then again you can omit the positive signs. 1 and 26. We will be dividing this number by 2 because 2 is the root. Okay, this 1 will come as it is. So this is going to be, this will come here as it is. 2 1s are 2. This is going to be 6. We will add. Okay, we are not subtracting, we are adding. 2 6s are 12. We are adding whatever is the sign, we are adding. This is 13. 2 into 13 is 26. Positive. This is 0. Now this is your coefficient of the other quotient. In other words, this is as good as x minus 2 and x squared minus 6x plus 13. This term will always represent the coefficient of x squared, this term the coefficient of x, and this term the coefficient of, or rather the constant term. You have to remember the last term is the remainder, and that's why we call it a remainder theorem for synthetic division. If the remainder is 0, then you know for a fact that this expression is a factor of the cubic that was given to us. Now how do we factorize 13? So 13 is a, it's a prime, so you cannot factorize 13. So at this point obviously you will have to use the quadratic formula to find out further roots. Okay, because it is in such a form that the mid split cannot be practiced. That is why I'll just leave it at this. So somebody asks you that what is the factor of this expression? The factor of this expression is this expression, which is x minus 2 into x square minus 6x plus 13. Okay, that's it. Thank you.